Welcome to Geometry Pre-AP. Today we're going to talk about proving triangles congruent. This lesson is also known as There Are No Donkeys or Roadside Assistants in Geometry. You'll remember those things and they'll be important later on in the lesson. So before today, in order to prove triangles congruent, you needed 3 pairs of congruent angles and 3 pairs of congruent sides. So 6 total pairs of information to prove triangles congruent. Today we'll learn the shortcuts so that you can prove triangles congruent with only 3 specific pairs of combinations, angles, and sides. So there'll be shortcuts that will help you out, make things a lot easier. So pause the video and write down all of these. I would have the pictures done too so we can explain those. Okay, so let's look at each one. The SSS theorem stands for all 3 sides of one figure are congruent to all 3 sides on another figure. And so that is important. If you have just those 3 pieces of information, then you can prove the triangle is congruent. So you don't have to have all 6 pairs. You only need the 3 pairs of corresponding sides. Okay. The next one is side angle side. And so in order to use that one, you have to have 2 sides and the included angle. So that's the important part right there, the included angle. So let's make sure we underline that, the included angle, and it is this angle right here. It is the angle formed by the 2 pairs of sides, and it's right here and right here. Okay, so 2 sides, one on each figure, and the angle that's created by those 2 sides. And so 3 pairs of information proves the triangle congruent. Okay, I'm going to skip this middle one. The angle side angle says 2 angles and the included side. So I see my 2 angles, one on each triangle, and the included is a side created by the 2 angles. Okay, so make sure you get that information all written down. Okay, and so then this next one, these last 2 right here, they are mixed up all the time. So it's very important that you pay close attention to these 2. All right, this one is the angle side, which has 2 angles and a non-included side that corresponds with each one. So you'll see this is the non-included side here, and it was by the double angle, so you have to have it in the same position on both triangles, and it's not included because it's the side not created by both angles, and so that is angle side angle, or that's angle side, and so we have angle side angle and angle side. Where that side is at for each of these makes a difference. Okay, and finally there's the HL theorem. The HL theorem has the hypotenuse and one of the legs are congruent on right triangles only. So you might be saying, well, you said 3 pairs. There's only 2 things here, hypotenuse and leg. But actually the third thing is that you have to say they're right triangles. If you don't say they're right triangles, then that's that third piece which makes 3 things. Okay, so now that you've got those written down, what we're going to do is we're going to practice with some, and we're going to see if we can mark the information that's given to us and determine which of these 5 ways prove the triangle is congruent. All right, but before we do that, I want to show you some of the information that can be added into pictures. So if we look at this picture here, we have triangle 1 and we have triangle 2. Okay, and so with those triangles, we can mark this side congruent to both triangles, and that is the reflexive property. Okay, they both share that side in common, and we've also talked about this where it's like this is A and B, so AB is congruent to AB. It's the exact same. If the triangles are flipped over, then will there be different letters? Now in this problem over here, we have 2 marks here on these sides. That is parallel lines. And remember, parallel lines create special angle pairs, so we'd have like this angle and this angle congruent. So that would be corresponding angles, but you can have any angle pairs. So look for parallel lines, and you can put congruent angles into the problem. Now in this case here, if we looked at the reflexive side, this would be AB is congruent to BA because the triangles are flip-flopped on top of each other. So this angle here is at the top, this angle here is on the other side. So the letters will be different for this reflexive property. Okay. Some other information we can put into our proofs that may not be given to us is that we have this one right here. We have the vertical angles. So we can add in vertical angles because remember that comes from the picture. Remember, you got to say the vertical angles, then you say the angles congruent to angle. Okay. Now, if you look over here at this last picture, there's a blue triangle and a red triangle. And the blue triangle and the red triangle both have this angle. And we can call that A. And so I have angle A is congruent to angle A. And that's reflexive property again. They both share that top angle. And so I can use that. But they both have to have that angle. The letters would be a little bit different, but they both have that angle. So these are the only things that we can add into pictures that are not given information. Everything else has to be given information. If it's not given to you, you cannot add it into the picture. So please understand these few things are the only things that can be added. All right, so here's our first couple practice problems. So pause the video and work on these real quick and just kind of get the pictures all drawn. Once you get your pictures all drawn, you can mark your given information in the picture, and then we'll talk about them. Okay, if I go in here, it has AD is congruent to CB, and DC is congruent to BA. And so that's this side, which corresponds to this side, which corresponds to the other side. I'll try to use different colors here. And so I've got two corresponding sides. There is another two pieces of information. But because they both share this side here in common, I can actually add in my third side for each triangle. And so these two triangles are congruent by side, side, side. And I can say triangle DBA is congruent to triangle. If I did DBA, it'd be BDC. All right. So that's that first one. On this one, we have AB is congruent to CD. We got this side is parallel to this side. So if I got parallel lines, I can add in some angles. Make sure you add in the right angles and look for the right transversal. The only angle you can add in here is this one and this one. People will mistakenly put that one and that one here. AD and BC are not parallel. And so we can add in the reflexive property also. And so when I go back in and look at this, this is a side and there's the corresponding side. We have an angle in here. We have an angle in here. And then we have another side and we have another side. So that angle is created by the two sides. So this would be side, angle, side. And so I would have triangle A, B, D is congruent to triangle C, D, B. Remember, we practiced naming those triangles like that back on Friday's lesson. All right, so let's look at this next one. We have AC bisects DB. So AC bisects this line right here, which means E is the midpoint for D and B. So that means these two parts are congruent. We have DE. Is congruent to BE. Actually, that's the same information. So actually, I need to fix this one. This needs to be switched. So this needs to be BD bisects AC. That's what I meant to have here. So let's correct that one. So that gives us another piece of information here. Now this one's bisected. Remember that we can add in vertical angles. So this is an angle. This was a side and a side. And then we have this other side here and here. And so we have an angle that's created by the two sides. So this is side, angle, side. And so how those are done, you have to understand how that order is written. That's two sides on each figure and the angle created by the two sides. Okay? All right, so let's go through this next one. Pause the video, complete these. Okay, so if you got this one done, all right, this one will be side, angle, side. All right, this one will be side, angle, side. This one right here will be HL. If you didn't get that one, it says angle A and angle C are right angles. So doesn't that make the two triangles right triangles? But it also says AB is congruent to BC, and then this is congruent. This is the hypotenuse for each side. This is a leg. So this is HL. How can I call it the hypotenuse? Because I have right triangles. Now this one had a right angles over here, and it had AD was congruent to, oh, hold on. AD was congruent to BC, and this is congruent to itself. So are these two triangles congruent? No, they were not. They're not in the right places. This is like a side angle side. This is like an angle side side. And so therefore those don't work. They have to be matching. So that one's a not congruent. My bad there. All right. Here's a couple more. Pause the video, write these examples down so that you can have your answers. Okay. This one is not congruent because we have angle A, an angle D, angle B, an angle E, an angle C, an angle F. Now, remember that the title of this lesson was there are no donkeys or roadside assistance in geometry? Because if I put the letters in here, there's an angle, there's an angle, there's another angle. And so that'd be angle, angle, angle. And remember I said there's no roadside assistance? That's because there's no AAA, which they use to help you with roadside assistance. That does not work. That does not prove triangles congruent at all. And if you try to use that, you will get it wrong. All right, let's look at this next one. A and D, C and E, and finally AC is congruent to DF. So here's AC and here's DF. And so the answer here is not congruent. They don't match up. That's two angles with the included side. This is two angles with a non-included side. So not congruent. Not everything is congruent. All right, let's put this last one in here. Pause the video, do these, turn the video on when you're ready to look at it. All right, so this one would be angle, angle, side. This one would be angle, side, angle. Parallel lines, this angle are congruent. Angle A and angle C are congruent, and this is reflexive property. So that's two angles and this a non-included side. That side's not created by this angle and this angle, so it's a non-included. If we go over here, angle ADB is this one, angle CBD is this one, ADB is here, and then this one's here, and then we got the reflexive side, so angle, side, angle. All right, now, we said there were no donkeys in geometry, so I'm going to draw one more for you that I want you to see and work with, okay? So here's a triangle. I'm going to duplicate it. Let's see here. There we go. All right, so if I had this information, all right, and then once I had this information, I was to go back and label this. This would be an angle and an angle, a side and a side and a side and a side. And so remember we said there are no donkeys in geometry because there are no ASS. There is no asses in geometry. So we cannot have an angle side side. And even if you spell it backwards, SSA, it's a donkey either way. And so it's not allowed. So if you use this, you're going to get it wrong. Now, there is one time where it does work, but your figure has to look like this. Because if you look at this figure and we put the information in this one, this is an angle, this is a side, and this is a side. Well, actually that's not true because that's no longer an angle. This is a right angle, which makes this a hypotenuse and this a leg, and since that's a right angle, so that would be HL. Because if I had two triangles that were like that, they would both have to have those marks. And so, therefore, if you get ASS, look for the right angle so that you can see that it is a hypotenuse leg. So watch out for that kind of stuff. Okay, don't get fooled. Make sure you know that what's the difference between this and side angle side? The angle has to be created by the side. So again, remember, one, two marks, and the angle created by the side. Okay, and so that wraps it up. You'll have two worksheets to practice with, and so good luck having fun with those.